So this video covers log equations again. This time we're going to have log equations that require those log properties that we learned in class. So here we have log of x plus log of 5 equals 2. First thing to remember here is that since the base on these logs isn't written, it is 10. These are common logs. These are both log base 10. So in order to solve this equation, we need to condense it so that there's only one log on this side of the equation. And to do that, we're going to use that addition property. So log of x plus log of 5 is equal to log of 5x. And we just use the addition property. And now that there's only one log, we can just solve this like the other log equations. So convert it to exponential. So 10 squared equals 5x. So that's 100 equals 5x. And x is equal to 20. All right. So next one, same idea, but with a few wrinkles added in. So we have subtraction here. So we can see that we'll end up using the subtraction property. But in order to use that subtraction property, we can't have a 2 in front of this log. The subtraction property only works when you have one log minus one log. So the first thing we'll do is use that power property. I can turn a 2, I can make that into an exponent on the input for that first log. So we get log base 3 of 2x squared minus log base 3 of 4 equals 10. And of course, 2x quantity squared is the same as 4x squared. And now I can use the subtraction property and write this as log base 3 of 4x squared divided by 4. And conveniently, on the inside of this log, we get the 4's divide to 1. Now, converting this to exponential form, we get 3 to the power of 10 equals x squared. 3 to the 10 is a very large number that I don't want to write down. But if I take the square root of both sides to solve, then I would get x equals 3 to the 5th, or x equals negative 3. However, if we know this is a negative number, and if we try to plug this in back here, we can't take the log of 2 times negative 3 to the 5th, so this one is in fact extraneous. And 3 to the 5th is 243 for those keeping score at home. Number 3, 5 to the 2x equals 20. So this, it's not a log equation yet, but what we do to solve this is we're going to end up taking the log of both sides of the equation. Since it's an exponential equation, but we can't write 20 and 5 with the same base. So instead, we're going to take log of both sides. And it's easiest to just take log base 10. So we have log base 10 of 5 to the 2x equals log of 20. The reason for doing this is that since we have log of something raised to an exponent, we can now use the power property to turn that exponent into a coefficient. So we get 2x times log of 5 equals log of 20. And now at this point, so we need to get x by itself. X is being multiplied by log 5 and by 2. So to isolate x, all I need to do is divide by 2 times log 5. So I get x equals log of 20 divided by 2 log 5. And this looks ugly, but remember, this is really just a single number. Log 20 divided by 2 log 5. And you could get an approximate value from your calculator. And the last one. So we have two options to solve this. We want to use that log property of equality, where I can cancel the logs out on both sides. But I can't use it yet because I have a 2 here. One thing I could do is move this 2 into an exponent. But doing that is going to give me quadratics on both sides of the equation. An easier thing to do is notice that I have a 2 here. So I can move this 2 down, make it a coefficient. So I have 2 times log base 5 of x minus 1 equals 2 times log base 5 of 4x minus 3. And then I can divide both sides by 2, so they go away. And now that I have logs on both sides of the equation, I can use the log property of equality and just ignore the logs and solve the inside part. So really I just have to solve x minus 1 equals 4x minus 3. And I get 3x equals 2. And x equals 2/3. However, if we check this answer, on the left side we get log of base 5 of 2/3 minus 1 squared, which comes out to 2/3 minus 1 is negative 1/3. That comes out to log base 5 of 1/9. So the left side is fine, but on the right side we get, if we do 2 times log base 5 of 4 times 2/3 minus 3, this gives us 2 times log base 5 of 4 times 2/3 is 8/3, and 8/3 minus 3 is negative 1/3. So this does not work. We can't have log of negative 1/3. And you might be thinking, but Mr. Trenfield, can't I bring this 2 into the exponent, square it, and make it log of a positive number? And the answer is not really, because the original expression here has the 2 in front. So even though there's a property that allows us to move this into an exponent, that property does alter the domain of what we're dealing with. And so it works for solving, but it's like when we square both sides. It can give us extraneous solutions. So this is extraneous, and we get no solution. All right, here. Your teacher is dumb and wrote the wrong problem. What he meant to write was, after how many years will the car be worth $2,000? So what we have here is one of these exponential word problems. But what's different is instead of solving for the final amount, what we're solving for is the time, which is the exponent. So if we set this up, we know that the final amount is 2,000. And it's depreciating at 15% per year. And it starts at 45,000. Times 1 minus 0.15 to the power of t. So we don't know what t is, unlike the other exponential problems where we knew the other amounts. Sometimes we had to solve for r, but usually we would have to solve for t. So first thing I'll do is divide both sides by 45,000. And I get we get 0.04 repeating equals 0.85 to the power of t. And here, since we have a variable and an exponent, the thing to do is take log of both sides. So we do log of 0.044 equals log of 0.85 to the power of t. Again, the reason for doing that is now we can use that power property of logs and move this t over here and turn it into a coefficient. So this now gives us log of 0.044 equals t times log of 0.85. And now to solve, all I have to do is divide by log of 0.85. And since these are base 10 logs, I can just put them in the calculator. And when I do that, I get time is approximately 19 years.